Should we move on to the next session here, which is still, we are still in the same context about responsible resource usage.
Okay, yeah, maybe Jørn also can join.
Hello. Yes.
Oh, yeah.
Oh.
Yeah, my camera doesn't work. But...
And maybe we should reintroduce, or you are still known?
Radovan and I both work at the University of Tromsø, and I do nowadays mostly like training, work on the local level, and also for the European supercomputer called Lumi. It's my daily bread.
Great that you are here. Also here now, the best way to participate will be, in this case, actually only to watch and ask questions and comment. I think from here on, we don't need to type anything anymore, I think. Do you want the screen? Should I have the screen? I think you wanted to start with something.
Because, yeah.
So take it from me.
Yeah. I can't do that. No, I'm currently not a host, so I can't take the screen.
Okay, I will make it. Yeah.
But I can already start. Like yesterday, we talked about transferring files, and today, today is about, or like now is about sharing resources responsible, and it also means like being clever about how you do stuff, because if it's faster for yourself, it also helps everyone else. Usually, or like if it's efficient for you, everyone else also profits. And now you should see my terminal. So I came up with a small example. So it's connected to transferring files. Radovan, can you see my screen and everything?
I can see it well. Looks good. So everybody else, just watch.
This is now on my local machine, and similar to yesterday, I just want to upload a folder, and there's different ways, as we discussed. So you could like just upload it. In this case, so the folder I want to upload is called. Yeah, you can see there's different. There's no colors, unfortunately, but this code folder is the one I want to upload, and it's not super large. I think we can see. Oh, that didn't help. It has like around 20,000 files, and you can check that with code. So it's 19,000 files, and I'm not sure how large it was, but it's also not that. Yeah, 200 megabytes. So it's not a particularly large folder. But it has quite a lot of files for the like little size. Quite a high number of files. So, and I want to upload this now to Saga. So, the easiest way would be scp -r, and then I have to code, and then I want to upload it to Saga. Sorry. And I just drop it in my home folder. So, okay, and if I do this now, this will take a long time. So I want to see how long it takes. So I write time in front. So in the end, it will give me an output like how long it actually took. So this will now just. So I will now upload all the files. And you see all the files are very small because they're basically instantaneously up. But it still takes some time for every file to be uploaded. So I will just like have this now running in the background, and then we can see how long it will take to upload this folder. And in the meantime, we can discuss other stuff, or like same topic maybe. Should we start with? I mean, you already now discussed a lot of quotas. So what do you think what does using shared resources responsibly mean?
Maybe we can. So if you carefully scroll down to the end of the page, it again links to a page on our documentation, and we can see what topics are there. What topics are there? So there is one topic is being kind to the login nodes and other users. Maybe we can start there, and then then later we can also talk about file transfer, and we will come back to that example. And in the meantime, it can copy. And also, I think you will then show us a much better way to transfer this file later.
Yeah. So I mean, this is one probably of the most common problems we notice when we have users on our systems, that the login nodes used in a way what they're not meant to be for.
Maybe a quick reminder, what was again the login node? So login node was, we have these, we can imagine a cluster is a collection of hundreds of little computers. And
yeah.
And we have a couple of those are login nodes, and they are only meant to be, so they are the ones accessible from the outside world. So when we log into Saga, we land on one of the, I don't know, 3 login nodes. And from there on, we manage our files, we move them around, we edit, we submit jobs. But the computations, the jobs, they are ideally, they are not running on the login node. So on the login node, there should be no job running. They get allocated one or many compute nodes. They run on the compute nodes, and once they finish, the compute nodes become available for other people. Sometimes there can be several calculations on the same compute node. So that's the distinction between a login node and a compute node. What are the things that we should do on a login node? What are the things that we should ideally not do on a login node?
I mean, I think in general, on the login nodes, you should not do any type of work which needs a lot of resources. So computations, I mean, the obvious. But so anything which uses a lot of resources for longer periods of times is not a good fit for the login nodes. Instead, I would say if you have something like you want to look at files, or you want to edit files, or there's these are the clear-cut cases. Like you have computational work should not be on the login nodes, and you have just starting jobs, writing job scripts, changing, I don't know, maybe input files, which clearly are on the login nodes, and then you have these cases where it's a bit trickier. And for me, this is always the prime example is always compilations, because compilations can sometimes take quite a while. But what is the reason why we should still why you sometimes have to basically use the login nodes?
I think you have to use it so the minimum is editing files, moving files around, creating job scripts, and managing job scripts. Maybe I can take the screen just for a minute and show something on the login node. I will steal it from you. Let's see if I can. Yes.
I would say the login nodes, compilations and installations, sometimes can actually take quite a while, but because the login nodes are the only ones in most clusters which have internet access, you sometimes have to do some installations there. So these are these corner cases where I would say it's for example, if you use EasyBuild, it will download files, and that only works if you can get around these if you have really, really long running compilations to do it somewhere else.
Yeah, so I will comment on that in a moment. Just making a note for myself. But one thing that you can also try if you are still on Saga. So I'm here on one of the 5 login nodes. One nice tool is Top. Maybe even nicer is HTOP. It's a little bit more modern. You can test it out. HTOP, enter. And it tells me that, well, on this login node, there are 64 cores. Most of them are not busy. This is good. If I now start a computation which will take 32 or 64 cores, well, then they will look busy, but everybody else will notice it. So that's why we want small things, editing files. About the network, it is possible to access network also from compute nodes. This goes normally via proxy. Normally it should work. If it doesn't work, please reach out to us. But I agree that it is a little bit more complicated there. And I wanted to comment on, if you want to get out of this, it's Q, quit, Q, boom. I wanted to also comment on the compilation that I personally like to put compilations also into a job script. I have to wait a little bit. Maybe it doesn't start immediately. Maybe it starts tomorrow. But it forces me to document it really well, because then I have to put all the module loads into my job script and I don't have to remember it. So it forces me to create nice documentation for what I did. And if I want to redo the compilation in 2 months, I just run the same script again. And then it runs nicely on a compute node. But there may or may not be a problem with the network, as Jørn said.
So that's what I meant, like these are corner cases, I would say. Like it sometimes makes sense to calculate or to compile on the login node. Sometimes it makes sense to compile on the compute nodes in the job script. In general, if it takes a long time, I would try to do it in a job script.
Yes, so great question, number 17. So how do we make sure that this doesn't happen? So if you start a job with sbatch or srun, salloc, there are alternatives. I think we didn't really talk about them. Then it will run on a compute node. What if I want? Sometimes I need to do something interactively because I don't know, I'm programming, I'm testing my new program, I'm testing my new job script. I would like to test it out live. I don't want it to sort of crash at 2 a.m. in the morning and me coming back to it again tomorrow. But I shouldn't use the login node either. So what is a good way then? This thing here.
Yeah, I mean, I like interactive jobs quite a lot. I use them often to try stuff out. When you're like, you're not sure if something runs, and you have to just like try it out maybe 20 times, and you don't want to start a job script. Wait, even in the fast queues, it takes probably like half a minute longer. So you're waiting, and then you say like, I forgot something here, and you change it. And for this, like an interactive job behaves just like a usual shell. So you can type something and you get it back. But instead of being on the login nodes, you are on the compute nodes.
Yeah. So it will look like I can really then interactively type and run, but I will get a compute node allocated for me for a certain amount of time, and I will get sort of moved into that compute node. And this is extremely practical when trying out new things. And you can have a look how that works. I think we will not say much more about it now.
No. I mean,
this we commented a bit.
Just because I recently had a case with, depending on how you do it, if you use salloc or srun, you sometimes also end up on a login node with the new shell. And then you have the feeling that you're like in an interactive session, but you're still on the login node. So please just try it out with hostname or look at the like prompt to see if you're on the login node or one of the other nodes, which usually start with a C and then some number and not login -1 or -1 or something.
Yeah, one thing that can be practical is into your script. If you interactively run a script, you can also put in here like hostname just to verify where is it actually running. We commented a bit on number of cores, amount of memory. We will not say more about it in 2 weeks, but here we have really nice documentation on that. Maybe we should, before going into the break, a few words about backup. So backup is good to think about because let's go back to the usage. Not all of these places are backed up. Some of them, so yes. But even though it says yes, the compute cluster still may not be. So this is not meant as a long-term archival storage for your data. So you really, it's your responsibility to move it somewhere else.
So the backups of especially the project folders are more meant in a way like you accidentally overwrite something, or you noticed you deleted your some temporary files, and I also deleted one of my output files I need, so I have to redo maybe like a week-long calculation, and then you can in the backup you will find your data still. But yeah, be aware it's on the work, it's not. So it's always a good practice if you do stuff on work because you need a lot of files or space to at the end of your calculation copy your files back to project, the output files.
Yes. So it's good to have a plan, good to discuss it with your colleagues, good to discuss it with your, I don't know, students or your PI to avoid, tears later. And maybe we can return to transferring data. Maybe you can take the screen again. Have we managed to transfer?
No, it's still running. But there's a question which I think is understandable. How does one directly run commands on a login node? Because for us, I think this is quite like intuitive what this means, but it's maybe not. So
should I show it or?
Yeah.
So let's.
I mean, you now just did a command on a login node.
Yeah, everything I type here is actually interactive, but this is fine because I did file operations edits. But let me create us some my command. Let's call it like that. And in my command, let's say I never heard about Slurm, so I will not do all of this. And here I run something gigantically big. Yes, and also we learned about executable, I think yesterday, or maybe the day before. So interactively now on the login node, this is now running on the login node. And if you have this htop, you might see it for like a few milliseconds popping up there. Of course, this will not use any resources, so I'm not afraid of running it. But it was there for a brief moment.
Also something if you're not sure if you maybe like do stuff which you shouldn't do on the login node, so if you like you're zipping like large file, like a large folder, or you're running something where you think, okay, this should only take maybe like 5 seconds and shouldn't take many resources, but you're not sure, then open a second shell, like just a second window basically. Also log into Saga, but be sure that you're on the same login node. So while it's running in one window, open a second one, and then just type htop to see, is it actually, maybe, because if you suddenly see that like all the cores are like fully loaded, then you might be, and you can also see it in the first line. If you now we don't see that much of htop, but if you scroll down a bit, it actually shows it's possible. Yeah. So now, for example, we see that there's like an rsync, which, or actually multiple rsyncs, which take quite a lot of like a few processes which take almost like a core each. So 100% CPU for percentage, you see that in the middle of like all the columns, means 100% is one core. So we have 64 cores. So if you use one core for a few minutes, that's fine. But if you use it for like, or multiple cores for like minutes, hours, then at some point it's not fine, because at some point other people will notice. And they will like
get complaints, and
then we have to kill your job and send you an email, and it's a lot of hassle.
Yes, and speaking of rsync, should we go back to this example?
Yes, we can.
So maybe take the screen for me.
Yeah, not much change from my side. Yeah. No. Yeah, sorry. Something is slow. I see it's still running.
And we tried it yesterday, and I think it took 20 minutes. And is there a better way?
Yeah, there's a better way. If we're like time pressed, I can also stop it, but I think we should be reasonably close to the end now. Because as we mentioned already, there's multiple ways of transferring data. You can just use SCP, you can use rsync, which sometimes is a bit better. But what we I think what we suggest, if it's just a file, just to use SCP, or if it's a tiny folder with like a couple of small files. But if it's something larger, like in the multiple megabytes, or especially if it's in the gigabytes or 100 of gigabytes, then compress it and tar it, because otherwise it will take forever. And it will also take resources and time from you and us.
And I think maybe, I don't know whether we need to show it or not show it, but if you would first tar,
yeah,
I mean, if you
can
would,
do that in a.
let's do it. So then we go from 20 minutes to seconds.
Let's. Yeah, I will take another screen now to that.
And I think we will maybe talk for 3 more minutes and then we will take a break.
Okay, so I'm still on my laptop. So instead of what I did before is SCP directly, what in this case I will do is I tar it first. So now you think you're filthy. It's
Yes.
verbose Z for compressing, and
yes.
F, is it?
Yes, correct.
Okay. And then I tell the archive name I want to give it. So just call it maybe archive on.tar.gz, because I use the Z, so it's zip. And then I wanted to use my code directory. Maybe I already did that yesterday. So let's see how long this takes.
So now it's putting all these.
I could have timed it. Yeah, so I could have timed that, but it's like less than 10 seconds. Let's see how big the file is now. I don't know. So okay. So this is now 98 megabytes. While before, maybe if you remember, I showed like the folder contains like 220 megabytes. Yeah. So I less than half of the size it has now, and it's just one file. And if I upload this one now, archive to hold on. Should have timed it, but let's see how long. I mean, also in the background, there's other file transfers still happening, so this might be a bit slower than it would otherwise be if I have no other files in the background. But still, we are 15 seconds or something. I think yesterday when I tried, it was like 8 seconds.
Yeah, so we
have
a factor of 60 here, so that's not too bad.
And now, of course, you have to I can log into Saga.
And then we need to extract it over.
That was not a slightly cheated way of logging in. And now I have to, so first we can see if it's here, archive, yes, and now we can
XF.
If I unpack it here now, then I will overwrite what I do in the other folders. Maybe I move it to a downloads folder. Nope. Don't have a good folder. It's put in the hello world. Okay, and now I can tar and XF and
the file name.
archive. Okay, I can time it. How long this takes? Because now we don't see what's happening because I left the V out, which would show us each file. I mean, tarring, if you tar this compression with Z, it takes longer than if you just basically bunch the file together in one big one. So
yeah, so this will be ready soon.
Yeah. It takes longer than I expected, actually, no?
Yeah, which is always a bit scary when the command takes longer than you expect. But, let's hope for the best here. Maybe we should take a break. The question is how long?
Yeah, before that, there is a question regarding building Conda environment on JavaScript. Maybe it's Jørn is the right person to ask the Conda question. Question number 19.
Question is it? Snake make. That question.
Yes.
Yeah, okay. Yeah, Conda is a bit of a problem. It's like it's hard to download files and do the installations separately. But on the other hand, Conda doesn't do compilation. It usually just like pulls complete like binaries. So Conda installations on the login nodes are fine. And SnakeMake, if it builds its own installation but doesn't run the job as its own Conda environment but doesn't run the job, is also okay on the login nodes. But if you but if you notice basically that it takes a long time to check with top or htop to see if it's actually just as an installation or if it does more. Something just as a side note now, sometimes you can also do like certain stuff, certain operations on the login nodes by restricting the program how many cores or threads it can use. So maybe just force it to have only 2 or 4 threads and not like, because many are set up so that it will use all the cores available and then you will fill up the whole node. It will be a bit faster, but everyone else will suffer. And if you only take like 2, then it's okay if it takes like 10 minutes or something.
But,
sorry?
But if you do it in JavaScript, that it's going to the compute node, and you may not have this internet connection. So is there?
I think there's a way, but I like from the top of my head, I don't know. If you have that problem or you can't find the solution, just write us a help.
Yeah.
Like a ticket.
Yeah, that's great. And in that note, I can say that the next session might be interesting for you, how to write to us. So we will take a break. Is there anything else which I might have missed?
I just wanted to mention, like, so the untarring took 1 minute and 30 seconds. So still, I mean, considerably faster than that. So, I mean, you can test it out. If you do like big file transfers more than once, try out the different options. Like try if it's faster to tar it and compress it with that. So gzip. Or try it what happens if you just do it without the compression. You can test that out.
Yeah, I recommend that all other questions keep them coming. We will follow up on them, but let's do them in writing.
Yeah.
How long should the break be?
Maybe 12 minutes, or do you need to shorten the break?
No, we don't.
Okay.
We don't shorten. So.
Okay, and we will be back 10 minutes to 12, 11:50. Yes, I think so. Yeah, welcome back, Radovan. And Jørn, please continue with how to ask support. And it's also good for us at Enrich staff, also how to respond to the support request. So, looking forward to it. Yeah.
Should I take the screen? So this will be the last session of today.
Just like I just want to show, like, since you like looked at it for so long, so it's just like uploading what otherwise would have taken 20 seconds took 28 minutes.
Why did it take so long? Does it have to do anything with the inodes that I mentioned? Actually, no, it doesn't. So what is it that made it 30 minutes?
I think what happens is that each and every file is like uploaded individually, which takes like the connection has to be set up. Then in the end, it's like checked that everything like worked, and then the connection is closed again, and that happens for each and every file. So it just takes each like little file with, like in this case here, you see the last one said like 72 bytes. So basically nothing, but if like the head, like there's maybe 200 millisecond like overhang and it like sets up the connection, closes it. So otherwise this would be like, I don't know, less than a millisecond, but without this overhead, it just accumulates each and every file. Just takes a bit of time, and together it takes 28 minutes. So while if you just have one big file, like a tar file, even if it's not compressed, the connection only has to be established once, and then they can basically just transfer files and don't have to do like other stuff. Yeah, so I hope this was a good example to show that it's like
it was
often worth it. Okay, yeah, take over.
Taking over, just a sec.